Sorry, just closing the door. Okay. So this is what we usually do in our high school math, or even maybe to a certain university level math. We'll be given some type of equation, and we'll be asked to say, what is the value of the function f, where the value of x takes on, let's say, the value of 1. And this would be fairly easy to calculate. You just plug in the value of 1 into the equation, and you get 1 squared plus 1 is equals to 2. Okay. Now, those of you who've done this, obviously all of you, there's a nice artificiality to this problem, to this situation, where we are somehow privileged to know the exact form of f. By form, the exact function f. We know that f is precisely x squared plus 1. How we have come to that information is something that is just conveniently ignored in most math classes. Okay. So for those of you who've done physics, maybe you're exposed to a bit of this in the physics world, of how we come to certain functions. The problem with pattern recognition is actually at a core level, particularly when we're doing pattern recognition with neural networks. Is at a core level, it simply becomes a way of estimating an f when all we know are the values of some independent variable and some dependent variable. In the case that I'm talking about now, there's obviously there's one independent variable and one dependent variable, but that may not be the case. So really, pattern recognition is going to be about, given some data that you have, right? Given some data that you somehow have. So given some data points, your job would be to estimate f. Now, it's actually quite interesting because if you really think about this, so let's say we'll just make up some data points here. 1, 2, 5, 3, 5, 4, 10.
Sir, 310?
No, 3, 5. Sorry, 4, 10. So 1, 2, 2, 5, 3, 5, 4, 10, 5, 12. Is that fine?
Yes, sir.
Yeah. Okay. So 1, 2, 2, 5, 3, 5, 4. Okay. So আপনাদেরকে কোনো একভাবে এই ডেটা দেওয়া হলো, কিভাবে আসলো, we simply don't know. We know that there's this data, and it is of importance to us to model where this data is coming from. Okay. Without obviously getting into any philosophical understanding of things, what we can say is the values of y. The values of y. So I am using the subscript yi to indicate 1, 2, 3, 4, 5 as an index. The value of yi is coming from some original function f, x of I, plus some noise. Is that fine? মানে এই পার্টটা নিয়ে কোনো সমস্যা?
No, sir. No, sir.
Now, understand that we don't know a few things. So, I urge you all to think it from the perspective of a computer, particularly the perspective of a von Neumann machine, not you using your human brain, which has evolved in many ways to do small-scale pattern recognition. Okay, not small-scale, but limited-scale pattern recognition, because there are certain patterns, obviously very big patterns. But most of you will be able to look into this and immediately come up with a formulation. right? But that is not what we're trying to do here. What we're trying to do is we're trying to develop a way so that computers can do this formulation with obviously human assistance. All right. So essentially what we're saying is y is there's some underlying function f which is dependent on the xi values, and then there's a noise, and there's a few things that we just do not know. We don't know the distribution of noise. Okay. We don't know the form of f or its parameterization. Okay. So for example, here is a potential parameterization of f, potential form of f, ax cubed plus bx squared plus cx plus d. Okay, so that is a form of f, and it may have the parameterizations 1, 1, 2, 0, where in this case a is equals to 1, b is equals to 1, c is equals to 2, and d is equals to 0. Okay, and I will simply now indicate the parameters by the tuple theta. এই এতটুকু কনভেনশনে কোনো সমস্যা?
No, sir. Clear.
No, sir. No, sir.
Okay. So if I bring to you a form of f, which is a e to the power x c x plus sorry. Maybe d is the one to use. Let's go with g. Okay, what are the parameters of this function?
Sir, A, B, C, and G.
A, B, C, and G, right? So you have this one, sorry, you have this one, this one, this one, this one. Okay. Now, at least in what we're going to start off with initially, the job that we'd like to do is the human being will need to choose the form of f hat, the form of f hat being our estimate of f. Okay, so again, we just simply have no way of knowing what is the true form or the parameterizations of f. We just don't have this. Amder eta jana nai, we just have to make a guess. There's just no other way. Okay, we can make certainly educated guesses, but these are all going to be guesses. So by looking at the data, we're going to make a guess about the form of our estimated f, and I'm just simply going to represent it as f hat. What we'd like to do is we'd also like to discover, given a particular form that we've chosen, what are the parameter values of f hat that is good. All right, and of course, because it's a pattern recognition course, what we will need to do is we'll need to come up with a definition of how is it that we measure goodness. All right. So now, if you guys look into this particular data, what form of a function do you think would be a good idea to choose for this data, for f hat?
Sir, a 6-degree polynomial.
A 6-degree polynomial. So let's go. Why a 6-degree polynomial, sir?
Because, sir, it would go through all the points.
Oh, sure. Yes. It would definitely go through all the points. But would that necessarily be, it is going through all the points really what we are after?
Not really, sir. We're trying to look for a general model.
Yeah, because if we go through all the points, now it's actually a very good observation, sir. If we go through all the points, suppose we have a function that goes through exactly all the points. All right. Remember, what we're trying to do is we're trying to estimate f, yeah? Yes, is that about right?
Yes.
But if we have a function that has gone through exactly all the points, what has that function also modeled?
The noise.
Nice. Okay. So in fact, by this very representation of y of I, we almost always never want a function that goes through exactly all the points. Did that make sense?
Yes.
Okay.
স্যার আবার বলা যাবে?
অবশ্যই ম্যাডাম। ঠিক আছে?
জি, স্যার।
Suppose I have arrived to this function. So let's say I've arrived to I have an underlying function f, and this noise. So for now, let's say this noise is my son randomly picking a number to add. এটা কি ঠিক আছে ম্যাডাম?
জি স্যার।
ঠিক আছে? So আমি x এর ভ্যালু একটা ফাংশনে দিয়ে কোনো একটা ভ্যালু আসতেছে. So for now, let's call it the real value of y. Plus there's some noise. And this noise is simply my son randomly picking a number and saying, "Apu eta jog koro." Okay? So, ami je measurement guli paisi, a measurement guli ki the real value, the actual, what is the underlying proper value, plus something that my son has just imagined out. ঠিক আছে? When we're trying to find the estimated function f, আমি যদি এরকম একটা মডেল বানায় ফেলাই যে এটা হলো এক্স্যাক্টলি এই ভ্যালুগুলিকে ফিট করে, আমি এরকম একটা ফাংশন ডিসকভার করলাম f of hat, যেটা এক্স্যাক্টলি 1 এর জন্য 2 দিবে, 2 এর জন্য 5 দিবে, 3 এর জন্য 5 দিবে, 4 এর জন্য 10 দিবে, 5 এর জন্য 12 দিবে, তাহলে আমি অ্যাকচুয়ালি কি f বার করছি নাকি f প্লাস আমার ছেলের র্যান্ডমনেস বার করছি?
f plus randomness.
এটা কি ম্যাডাম বোঝা যায়? স্যার, থ্যাংক ইউ।
জি স্যার।
Okay, because the randomness here can be just measurement errors. It could be an instrument problem, or it might be just something intrinsic to the instrument. Make sense? You're not going to get out of this. It's part of any measurement. Make sense?
কিন্তু স্যার এখানে তো তাহলে আমরা মানে f of x এর মেইন ফাংশনটা বের করতে পারলাম না, তো স্যার র্যান্ডম ভ্যালু সহ একটা মডেলের মতন তৈরি করলাম।
অবশ্যই স্যার, মানে আপনি কি জীবনে কোনো জায়গায় f of x এর রিয়েল ভ্যালুটা আদতে পাবেন ম্যাডাম? আপনি একটু চিন্তা করে দেখেন, আমি যদি আপনাকে পিওর শুধু ডেটা দিই এবং আমি আপনাকে f এর ফর্ম সম্পর্কে কিচ্ছু বললাম না, আপনি কিভাবে রিয়েল ফাংশনটা জানবেন?
জি স্যার, জানা তো সম্ভব না ডেটা থেকে।
মানে আমার মাথায় আমি একটা ফাংশন ইউজ করে এটা বানাইছি, হ্যাঁ, বানায় আমি কয়েকটাতে ধরুন র্যান্ডম নয়েজ আমার মাথা থেকে অ্যাড করে দিয়েছি। আমি যদি আপনাকে না বলি প্রিসাইসলি আমার মাথায় এক্স্যাক্টলি কি ছিল কোন সময়ে, তাহলে আপনি কিভাবে খুঁজে বার করবেন যে আমার মাথায় কি ছিল? আনলেস ইউর গড, বাট অ্যাসিউমিং দ্যাট উই আর লেস ডিভাইন হিয়ার, তাই না? মানে
জি স্যার, বুঝতে পেরেছি।
there you're always fighting the fact that you don't know the underlying distribution. Now, just think about this. If someone comes and asks you, what is the underlying distribution of the English language? Truthfully, you actually cannot give an answer because the underlying distribution of the English language is always going to be biased by the sample that you've collected the distribution of. There's no guarantee that the real distribution is somehow represented by your sample. Make sense?
Yes.
Yes sir.
Okay, but it may sound difficult, but this is the reality that we have everywhere. When we're doing these vaccine testings, they're only as good as the samples that we're doing. That's why, for example, when you look into, I know this is not relevant necessarily to pattern recognition, but it is actually interesting when you're interpreting data. The Moderna vaccine was tested in summer, mainly dominantly in the United States. The Oxford vaccine was tested across multiple continents and multiple weather conditions. So if the Oxford vaccine has a lower efficacy compared to Moderna, you cannot just interpret those two numbers to be saying, oh, you know what, Oxford is poorer than Moderna, because there are underlying concerns that you have to take into account. But then these are the things that you know. There might be other things that you simply just don't know. Okay, every random sampling is not really that random. Make sense? The things that you don't know are the stuff that introduces this noise.
স্যার
Okay.
ওয়াই ভ্যালুগুলো স্কেলার প্লট ড্র করে লাইন ড্র করে দেন তো স্যার আমরা কোএফিসিয়েন্ট গুলো পেতে পারি প্রোগ্রামিং টুল।
Sure. Yeah. So now we are coming to the next part of why is it that what is it that we need? Really, the question we should be asking is why is it that we want to do an estimate of f to begin with? আমাদের এটা দরকার কি ছিল? মানে আমাদের তো এই ডেটাটা আছে, তাই না?
ইয়েস স্যার।
Yes, sir.
তাহলে আব্দুল্লাহ সাহেব যে বলেন স্ক্যাটার প্লট ড্র করে করা, this is absolutely fine. Okay, so I'll just point out two problems just a bit later, but before getting to that, আমাদের এইটার একটা ফর্ম এস্টিমেট করার তো কোনো দরকার নাই আমাদের যদি ডেটাটা থাকে। Why is it that we want to estimate this f hat?
স্যার স্যাম্পল ডেটাটা তো দেয়া থাকবে স্যার, স্যাম্পল ডেটা থেকে আমরা কোএফিসিয়েন্ট গুলো পেলে দেন আমরা নেক্সট এস্টিমেশন গুলো বের করতে পারবো, লাইক 12 এর পরে যদি 15 হয় তাহলে কি হতে পারে।
Okay, so there's actually stuff that we'd like to do. I think this is your answer, but we want to estimate f of hat so that we can get estimates of y at I for i's that we have not seen. Actually, for xi's that we have not seen. So maybe it doesn't have to be just the fact that it is beyond x equals to 5. We may want to get the value of yi when xi is equals to 3.2. চাইতে পারি না? Okay. We may now want it when x is equals to minus 20 or when x is equals to 500. Okay. The problem, as you will see, is that right now we only know the behavior of the underlying function for a limited domain of my data. I actually don't have exposure in the other areas. Okay. So whatever nature that I determine the form of f to be is going to be biased by the data that I have, the domain that I have so far. এটা কি বোঝা যায়?
Yes,
Yes,
sir.
sir. Yes, sir.
Good. So now, but you know what? বেশি চিন্তা করলে তো আসলে কোনো কাজ আগাবে না। Okay. So what we'd like to do is, I'm sure you guys have all heard of Occam's razor. There's actually a formalization of Occam's razor, but we will leave that aside. So let's choose a function that we think will in general follow the trend of this data. What would be the form of that function?
Sir, it would be a non-decreasing function.
It would be a non-decreasing function. Very good. So that would mean that at least in this domain, or between 1 to 5, the gradient will be positive. Okay. So can we, for example, use this form, f of yeah, let's just use the simplest one for now. আমরা কি এটা একটা ইউজ করতে পারি?
Yes, sir.
We could have chosen, so for the algorithm that we are developing, I have chosen the linear form now because it's just easier to do the math on the linear form. But for the algorithm that we want to develop, really what we wanted is that it should really work with any form of the function, any form of a function. So it should really be able to work with this one. Okay, that should just be written as CPX really. এটা নিয়েও যদি কাজ করতে বলি, it should be able to work with that. So the algorithm that we want to develop is going to be responsible for estimating the values of the parameters because we will choose the form. আমরা যদি এই ফর্মটা চুজ করি তাহলে the algorithm should help us estimate the parameters. আমরা যদি এই ফর্মটা চুজ করি the same algorithm should help us estimate the parameters. Make sense?
Yes, sir.
মানে আমরা ওই জায়গায় যাইতে চাই। সমস্যাটা হলো কি লিনিয়ার ফাংশনের জন্য because we are very good at math when it comes to linear functions. ঠিক আছে, মানে আমরা লিনিয়ার ফাংশন খুব ভালো পারি মানে হিউম্যান বিংস হিসাবে, হ্যাঁ। And we have developed entire courses called linear algebra, right, which is to do with linear functions. So we are very good at it. So there's a chance that you guys might fall into a sense of safety saying যে আচ্ছা লিনিয়ার ডেটা হলে তো আমি এই সহজভাবে বার করতে পারি, but that doesn't help us generalize the algorithm to complicated forms. And we want to develop an algorithm which is also going to work for complicated forms. Okay, good. So now let's choose the form y equals to ax plus b for now, and it's just coincidental, maybe intentionally coincidental, but coincidental that we've chosen a linear function. So I am going to propose an algorithm now for this data, and then we will base our work on that. From that initially, then we will change the algorithm, because as you'll see the algorithm is actually, for the lack of a better term, absolutely terrible. Okay, so f hat of x is equals to ax plus b, so theta is equals to well, it's a and b, so I'm going to initially choose theta with some random value of a and with some random value of b. So here I will just go with VA and VB. VA and VB are simply random values of A and B. Okay?
Yes, sir.
Okay. So here is my amazing algorithm. And as you guys will see, this algorithm will work while the world does not end. Calculate theta good equals to theta. Calculate goodness of theta if goodness is greater than Okay, so let's have a look at that algorithm. I have f hat of x, which is ax plus b. I have chosen a random theta, and I have assigned theta good to be theta. I've started a loop. The loop will continue until the world does not end. I will calculate the goodness of theta. Okay. In fact, I will calculate the goodness of, let's be more precise, of f hat theta x. So I will calculate the goodness of the function f of hat when parameterized by theta. If goodness is greater than goodness of, let's actually be more precise there. because we're calculating the goodness of the function, not of the parameters. Oh, marattok avastha. Then I say theta good is equals to theta, and then I change theta to some new random values, VA and VB. I keep on going. Will this work?
Sir, it's non-deterministic, but it would work over a very, very long period of time.
Sure. I mean, eventually, like, we're going to end up with some, given enough time, right? We're going to end up with theta good being a good estimate of theta, right?
Yes.
Yeah. But we can all agree that this is a bad algorithm. Can we at least agree that this algorithm is probably not the best way to approach the problem?
Yes, sir, definitely.
Yeah. But there is something here. There is something here that needs to be defined, which we haven't defined yet. Like even for this Pocha algorithm to function, we still need to define what is it that we mean by goodness. Make sense? Because we say this amazing thing that we want to calculate goodness. So how is it that we calculate goodness? Okay, and so let's think about calculating goodness. So I have y now. Now, because I said that we're going to initialize theta with VA and VB, which are random values. So let's initialize it, theta to be, let's say 1, 1. 1, 1 is going to give me the form f hat of x is equals to ki hobe tele?
X plus 1, sir.
It would become x plus 1. Right. So if it is x plus 1, then what are my values of estimated values of y?
2, 3, 4, 5, and 6.
2, 3, 4, 5, 6. If I now change theta to be 3, 0, then f hat of x becomes
3x.
x. Okay. What are my values of estimated values of y?
3, 6,
3, 6,
9,
9,
3, 4 is 12,
12,
and 15.
15. Right? What happens if I take my estimated value of theta to be minus 5, 2?
Minus 5x plus 2.
Yes, beautiful. Now tell me the values.
Minus 3.
Minus 3. Whoa, really? Minus 5 hat. Yes, sir. Minus 3.
Then minus 1.
Minus 1. Minus 1. Minus 5 times 2 is minus
Sorry.
10. Minus 10 plus 2 is minus 8.
8. Yeah.
Would it be minus 8? Minus 13.
Minus 18.
Minus 18.
Minus 23.
Minus 23. Okay. So now let's calculate the goodness of each of these. Goodness. Okay. So what is the upper limit of goodness? So how are we going to measure something that is a perfectly good thing? Someone?
So we can measure how terrible it is, or in other words, the error.
Right. So I think that so we want to get to that, and we will calculate the error. But I'd like to sort of pause and just take 2 minutes to understand that when we're calculating goodness, there's an understanding that we will now need to ascribe an upper limit for saying this goodness is perfect. And we tend to do that when we're grading exams. We say that 100 out of 100 is the perfect score. However, a step, enforcing an upper limit for goodness is actually quite difficult when we're measuring the goodness of some parameterizations. What is easier for us to do is to measure the badness. All right, is to say how bad it is. And we say when badness is 0, then it is the most good. Did that make sense?
Yes.
Okay. Now badness, on the other hand, badness has many names. So we're gonna write down some of these names here, which is badness. This is a name that is invented by myself, obviously. There's error. There's loss. Okay. They all essentially mean the same thing. Our current estimate টা কতখানি ভালো না আমি এটার একটা মেজারমেন্ট করতে চাই ঠিক আছে alright
Okay, sir.
so now we should probably establish what is the lowest bound for what is the lowest possible number for badness or error or loss. What is the lowest value it can take?
0.
0. Okay. And potentially we will have the value of 0 when my estimates, when my predictions, so now I'm using the term predictions, right? So my estimated function is going to take the values of the independent variables and predict a value for the dependent variable. So the least amount of badness you would say is going to happen when my predictions match exactly my ground truth data, my values of y. Would that be a reasonable thing to assume for now?
Yes.
Yes, sir.
Okay, so now we'll be very careful. So I'm going to say that আমরা যদি ঠিক এই exact এই ডেটাটা প্রেডিক্ট করি তাহলে আমাদের badness বা error বা loss হবে 0. এটা কি ঠিক আছে?
Yes, sir. Yes.
Now, it's a very important observation because that now you guys should understand that with the conversation that we had in this, I don't want to call it a slide, but in the page before, you'd imagine that we actually never, ever want to hit a badness value of 0. Because a badness value of 0 would mean that আমরা কি করে ফেলেছি?
We would have modeled the noise as well.
We have also modeled the noise. Did that make sense?
Yes, sir.
Okay. So while this is a useful measure for us, understand that because this is not an exact mathematical discipline, it uses math, but this is a discipline that has to deal with real world problems, which we don't necessarily understand very well from a mathematical perspective. So we are using a mathematical construct to measure badness, error, loss. However, you should know that by coming to a perfect loss value, you have come to an estimate which is actually probably not going to be very useful. Okay, most of the time it is not going to be very useful. Okay, so really we want to hit a sweet spot where our loss value is low, but it is not too low. That's really the spot that we are after. Okay, and as you'll see, by choosing this form of f, we have pretty much ensured that we will never hit a loss value of 0. Because you will it is not possible for you to get a linear function that actually fits those points. Make sense?
Yes, sir. Yes.
Yes, sir.
Okay. So the term that I'm going to use here is we are underfitting the points. We are underfitting the data points in the hope to get a generalized function. By generalized function meaning that it's the function that will hopefully generalize for other data points except for the ones that we've got, which is generalizability of the model. So the generalizability of the model is the ability of the model to make good predictions for data points that it has not seen. Okay, I'm sure there's a better definition out there, but this is the working definition, at least for me. এতটুকুতে কোনো সমস্যা?
No, sir. Clear.
All right. So now, what's interesting is we have measured the loss or the error or the badness of the original y data values to be 0. And we can also, I think, agree that this must be the lowest possible value of this measure. And we should never ever have a negative badness. Okay, because a negative badness would be an indication of goodness. Make sense?
Yes, sir.
All right. So now I would like to measure the badness of the first parameterization. Okay. How can we go about measuring the badness? Give me some options.
Sir, we can consider adding the absolute differences.
We can consider the absolute differences. Why is the absolute difference important?
Because we may predict positive as well as negative, and if we add both of them, we might end up with a misrepresentative of the error.
Also, it's important to make sure that you get a minimum of
0.
0. Because if you don't take the absolute difference, you may very well end up being just a fully negative error. Error value. এটা কি বোঝা যায় সবাই?
মানে আমাদের 0 থেকে বড় ভ্যালু পেতে হবে।
0 বা 0 এর চেয়ে বড় হইতে হবে আমার মেজারটা। মানে এর চেয়ে ছোট হওয়াটা আসলে উচিত হবে না, তাই না স্যার?
ইয়েস স্যার।
ওকে, মানে তুমি সবচেয়ে ভালো ছাত্র, মানে তুমি সবচেয়ে কম পচা ছাত্র। সবচেয়ে কম পচার ভ্যালুটা কত হবে? 0। মানে 0 পচা। Did that make sense?
Yes, sir.
Okay. Right. So now let's
স্যার তাহলে কি আমাদেরকে এটা এইভাবে ব্যালেন্স করতে হবে যাতে 0 থেকে ছোট চলে না আসে বা নেগেটিভে চলে না যায়?
Yeah, exactly, madam. So that's why instead of taking just the difference of the individual values, so আমরা এই দুইটা ডিফারেন্স নিতে পারি। So এই দুইটা ডিফারেন্স, ফর এক্সাম্পল 2 প্রেডিক্ট করার কথা 2 প্রেডিক্ট করছে, পারফেক্ট, তাই না ম্যাডাম?
জি স্যার।
এইটার ক্ষেত্রে তো পারফেক্ট। আচ্ছা, এইটার ক্ষেত্রে কি এটা পারফেক্ট?
নো স্যার।
আচ্ছা, তো ভুলটা কতখানি?
2।
আমরা স্কয়ার করে দিলে তো নেগেটিভটা রিমুভ হয়ে যায় না স্যার?
Absolutely, আমরা স্কয়ারও করতে পারি, রাইট? বাট দ্য পয়েন্ট ইজ হিয়ার দ্যাট আমরা যদি এইটা, সো ম্যাডাম জাস্ট হাইপোথেটিক্যালি এটা যদি 3 এর জায়গায় 7 হইতো তাহলে ডিফারেন্সটা কত হইতো?
-2 চলে আসবে।
কিন্তু -2টা কি একটা মানে আমাদের জন্য ইউজফুল মেজার হলো?
না স্যার।
Right. So really what we want to do is we want to convert -2 and 2 to be 2. এটা কি ঠিক আছে?
Yes, sir.
Yes.
Okay. So that's why the suggestion of the absolute value. The other way is, of course, that we can just take the square of the differences. Make sense, madam?
Yes, sir.
Okay. The exact form of the error function can change. There's two important things that we need to make sure for the purpose that we've got now, is that the errors on a per sample basis must be positive, and the errors are calculated consistently across the samples. And it is calculated the same way. আপনি একটা জায়গায় absolute আর একটা জায়গায় square যেন না নেন। Make sense?
Yes, sir.
Yes, sir.
In fact, I have misspoken. What we must ensure is the errors individually must be 0 or positive. It doesn't just have to be positive. Okay. So now, আমরা absolute value নিয়ে যদি করি আসলে নাম্বারগুলি ছোট হবে। আব্দুল্লাহ সাহেব নইলে কিন্তু আলটিমেটলি আমরা স্কোয়ার্ড এররেই যাব। ঠিক আছে স্যার? কিন্তু মানে এই কাজটার জন্য এখন আমরা একটু অ্যাবসলিউট ভ্যালু নিয়ে করি, কারণ তাইলে নাম্বারগুলি ছোট ছোট হবে, যোগ বিয়োগ করতে সুবিধা। আপনারা দয়া করে সবাই একটু ক্যালকুলেটর বার করেন, কারণ আমি এই ক্যালকুলেশনগুলি মাথায় করার সক্ষমতা রাখি না। ওকে, সো লেট আস বিগিন। এররগুলি আমি লালে লিখি, ঠিক আছে? প্রথম এটার এরর কত?
0
0
এটা
2
এটা
1
এটা
5
5 এটা
6
আচ্ছা টোটাল এরর কত?
14
অ্যাভারেজ এরর কত? মিন এরর কত?
14 over 5, so 2.8.
2.8
ঠিক আছে এখন আসেন এটা
1
1
1 4 7 2
2
2 3
টোটাল
11
11,
মিন
2.2.
2.2 এখানে
Sir, 5.
5
Sir, 13.
13
18
18
28
28
তারপর হচ্ছে 35
35 টোটাল
99.
99 ওকে মিন
19.8.
19.8
Yes.
okay thank you okay and for the sake of not just doing it let's also take theta equals to 2 0 that gives us f hat of x is
21
equals to 2 of x তাহলে এটা হবে 2 4 6 8 10 হবে না
জি,
ভুল
sir.
করলাম নাকি আসেন তো এটা হবে 0 1 1 2 2 any problems so far
No,
No,
sir.
alright so এটা টোটাল করলে কি হবে
6.
6
total goes to 6 mean
1.2.
1 now you see the mean error is actually quite important and the reason why it's quite important is it actually gives you the error per sample because I now have 5 samples right and now if you calculate the total error over 5 samples and let's say you've got 14 if someone else if another colleague of mine was working on let's say a similar problem but he has a data set of 20 elements his total error and my total error are just not comparable make sense
Yes, sir.
yes sir
so the mean error is almost always a better discussion to compare things now I understand we're comparing things of all between the 5 elements but I just want you guys to get into the habit of understanding that when we're calculating loss, what we really want to talk about is mean loss. We don't want to really talk about total loss because total loss is dependent on many things. Well, the other thing, of course, of being, how many samples am I calculating the loss over? Particularly when it comes to neural networks. So, for example, Mushfiq Shahab হয়তো একটা data set train করতেছে, আমি করতেছি. আমার batch size হয়তো 128. It's something that we'll discuss later. Mushfiq Shahab probably has a bigger GPU and he's probably calculating on a batch of 256. ওনার loss value, total loss value বেশি হওয়ারই কথা। ঠিক আছে? He has double my samples when he's calculating loss. But really the conversation we should be having is what is my average loss? Okay?
Yes.
Okay. So এখন বলেন, yeah, please go ahead.
কোশ্চেন সেটা হচ্ছে
Yeah.
এখানে আমরা এটা করতে পারি না যে মানে বেসিক্যালি একটা মডেলের যে আমাদের লস ফাংশন সেটা তো আমরা ওই যে মিন অ্যাবসলিউট এরর বা ডিফারেন্সিয়াল এরর যদি ডিফাইন করি তারপর এটা ইভ্যালুয়েশন করি একটা ইভ্যালুয়েশন ম্যাট্রিক্স দিয়ে যেটা রুট মিন স্কয়ার এরর বা মিন অ্যাবসলিউট এরর দিয়ে তাহলে এটা হয়ে যায় না
Sir, I mean, it took question time. I just want to make sure I understand the question. So evaluation metrics and loss they are not, they may be the same thing, but they don't have to be. Did that make sense?
Yeah, okay.
Okay. So with that, can you now repeat your question?
এই দুটো যদি সেম থিং না হয়ে থাকে তাহলে আমরা যখন একটা লস ফাংশন ডিফাইন করি তখন তো আমরা যে একটা মিন এরর হিসেবেও নিতে পারি, তাই না?
আমরা মিন
বা
অ্যাবসলিউট এরর নিতে পারি, আমরা রুট মিন স্কোয়ার এরর নিতে পারি।
এখন এটা যখন মডেলের মধ্যে যাওয়া হয় তারপর ইভ্যালুয়েশন করতে চাই যে এটা মানে ইভ্যালুয়েশন ম্যাট্রিক্স দিয়ে এটা ইভ্যালুয়েট করতে চাই, তো সেটা হলে মানে এটা লসটা আমরা তখনই এইভাবে ক্যালকুলেট করা হয় না?
Sure, sir. The problem, of course, is that for most of the applications that we will see in this course, evaluation metric গুলি আসলে loss হিসেবে use করা যাইতো, provided that, and we haven't come to that yet, but provided that evaluation metrics এর calculation গুলি differentiable হয়. Did that make sense?
Okay.
The problem that we have is evaluation metric guli quite a lot of the time is just not differentiable. And because they're not differentiable, they don't fit in within our gradient-based learning. Because we need to differentiate the loss function to find the gradients. Did that make sense?
ডিফারেন্সিয়েবলটা এটা ডিপেন্ডেন্ট কি ডেটা সেটের উপরে নাকি মডেল যেটা ইউজ করছে?
আপনার লস ক্যালকুলেশনটা অ্যাকচুয়ালি, সো ফর এক্সাম্পল আমরা এখানে যে ক্যালকুলেশনটা করলাম লসের জন্য, এইটা একটা ডিফারেন্সিয়েবল ফাংশন। এটা ডিফারেন্সিয়েবল ফাংশন আমরা দেখবো স্যার, কিন্তু আপনি এটা মানে আমরা যেভাবে ক্যালকুলেশনটা করছি এটা আপনি ডিফারেন্সিয়েট করতে পারেন। ওকে, কিন্তু ফর এক্সাম্পল let us say something like the ROI, the region of interest, the ROI overlap that we are calculating for object detection. এটার ক্যালকুলেশনটা এরকম যে এটার ক্যালকুলেশনটা আসলে ডিফারেন্সিয়েবল না, মানে আমরা এটা ক্যালকুলেট করতে হবে কেন এটা আমার মেট্রিক, কিন্তু এটা আমাদের জন্য ডিফারেন্সিয়েবল একটা মেট্রিক না। Did that make sense? Okay. You'll see, and in fact accuracy calculationটাও যদি আপনি করে দেখেন, it becomes very very hard. Like you can try to approximate it, but it is not actually going to be it's not a very nice measurement that you can easily differentiate. That seems to be the challenge. However, having said that, there's actually, particularly in the case of neural networks, you find that what you're really after is obviously the metrics that you're optimizing for. But quite often you also find that optimizing for multiple things, even things which are not directly related to to your end goal, actually produces a better output, better result than optimizing for a single thing. এটা আমরা দেখব স্যার সামনে ইনশাআল্লাহ। Okay. All right. So now let's come back to this. Which model would be, আমরা কোন থিটাটা চুজ করব স্যার এখান থেকে?
Last one is better.
The last one is better so far. Okay. এখন point though is what we've done, partly due to my fault, is we initialized theta randomly. We got something. Then we chose another random value of theta and we got something. We chose another random value of theta, got something. And we chose another random value of theta, got something. আমরা যদি একটা মেশিন হিসেবে এটা করতাম, if I keep on choosing things randomly, this would be a rather poor exercise. But I can actually go on forever before I hit a good point. Make sense?
Yes, sir.
All right. So now let's actually see how is it that we've calculated this, because that's going to help us. We calculated the loss L by 1 by n being the number of samples in my training data. Okay. Now, why is it the training data? Because I am calculating the goodness and the badness of my parameterization based on the training data, on this data. That's why I'm calling it training data for now. Okay. So 1 by n. Then I'm taking the absolute value of f hat theta of xi minus yi, and I'm summing over I equals to 1 to n. Is that about right?
Yes.
Yes.
Okay. Now, an alternative loss function would be 1 by n, summation of I equals to 1 to n, f hat of xi, parameters by theta, minus yi whole squared. I think this is the one that Abdullah sir or someone was mentioning, which is mean squared error.
Yes, sir.
Both of them would be measurements of error. Is that about right?
Yes.
Okay. So now that's very interesting, right? Now, let's think of this function here. This function can now be rewritten as one by n, I equals to 1 to n, a xi plus b minus yi লিখতে পারি?
জি স্যার।
Yes, sir.
Which can now be rewritten as 1 by n, I equals to 1 to n, a plus b minus 2 a plus b minus 2 absolute plus 2a plus b minus 5 absolute plus 3a plus b minus 5 absolute plus 4a plus b minus 10 plus, oh, I'm running out of space, 5a plus b minus 12. Ish, sorry for the really really bad writing, but আমি কি এই উপরের ফাংশনটাকে এইভাবে লিখতে পারি না?
জি স্যার।
Yes, sir.
জি স্যার, পারি।
এতটুকুতে কোনো সমস্যা?
No, sir.
No, sir.
Okay. So now the question is, given this form of the function, okay, আমার যে লস ফাংশনটা আছে এটা যখন আমি আমার ট্রেনিং ডেটার উপরে লিখলাম, এই লস ফাংশনটাকে যদি আমি এক্সপ্যান্ড করি আমি এরকম একটা কিছু পাই, তাই না?
Yes.
Right. So now what does my absolute function look like?
So for the positive x-axis, it would be y equals to x.
Let's actually plot it against a. Can I plot it against a?
Yes.
Because my loss is a function of a and b right now. It's actually not a function of x. In what I've written it down so far, ekhane, my loss is a function of a and b, তাই না?
Yes, sir. Yes, sir. We can use it.
so my loss is now no longer a function of x. Make sense?
Yes, sir.
And in fact, that makes a lot of sense for us, right? Because if you think about it, our y values and our x values are pretty much fixed. The things that we are changing are a and b. So our loss should really be a function of our parameters. Yes?
Yes, sir.
মানে এটাতে কারো কোনো সমস্যা আছে এটাতে? Good. So you'd imagine that my loss is probably at value of a equals to 2 এর কাছাকাছি my loss is probably at its lowest. Would that be about a right assumption? Maybe not at exactly 2, but 2 point something. এই জায়গাতে my loss would be at its lowest value.
Sir, we will get different values depending on b, right?
Yeah, so but as I vary a, my loss values will change if I hold b fixed.
Yes.
Yes, sir. Minimum 2 এর কাছাকাছি হবে, স্যার।
So if I hold b to be fixed, so let's assume for now that the value of b is 0, for now, just for the sake of discussion. Okay. But if I assume that my value of b is fixed, and for this discussion now, just to plot the graph, I say that my value of b is 0, then my value of a, মানে roughly around এই জায়গায় কোথাও এটা মানে minimum কোথাও হবে এই জায়গার মধ্যে কোথাও?
Yes, sir.
And the value is probably going to be, a positive loss value, because I don't think we can ever hit 0. এটা তো সম্ভব না, but not with a linear function. এতটুকুতে কোনো সমস্যা? মানে এই দুইটা assumption কি আমরা এই গ্রাফটা প্লট করার জন্য খুব বেশি পচা হয়ে যাচ্ছে?
No, sir, it makes sense.
স্যার আমরা মিনিমাম 2 টা কিভাবে ধরলাম স্যার?
এটা স্যার একদম স্বপ্নে পাওয়া, স্যার একদম পিওরলি স্বপ্নে পাওয়া। ঠিক আছে স্যার, কিন্তু মুশফিক সাহেব আপনি যদি একটু চিন্তা করে দেখেন, ঠিক আছে, এই ফাংশনটায় আসলে যখন 3x যদি আপনি নেন তাহলে আপনার লস আসে কত? 2.2।
ইয়েস স্যার।
আর আপনি যদি আসলে 1 দিয়ে ক্যালকুলেট করেন, শুধু 1 দিয়ে ক্যালকুলেট করেন, তাহলে আপনার লসটা এটার চেয়ে বেশি আসবে।
ইয়েস স্যার।
মানে আপনার লসটা আসলে এই 2 এর আশেপাশে এদিকে বেশি এদিকেও বেশি। Did that make sense?
ইয়েস ইয়েস।
তো আপনার লসটা এখান থেকে আসলে এখানে বেশি, তারপর কম, তারপর আবার বেশি, এরকম করে আগাচ্ছে। Did that make sense?
ইয়েস স্যার।
মানে আমি I have just sort of gone over that, কিন্তু আপনার ইচ্ছা করলে আসলে ক্যালকুলেট করে দেখেন। যদি
স্যার মানে আমরা ধরে নিলাম আর কি।
না ধরে নেন না, আমরা আসলে এটা করি স্যার, ঠিক আছে, because I think it would be a good exercise. So let's take theta equals to 1 0. So my f hat of x is equals to x. So আমি পাবো কি 1 2 3 4 5। আমার টোটাল এরর কত আসবে? এখানে আসবে 1, এখানে আসবে 3, এখানে আসবে 3 2 6 7. So 10 11 16 18, ঠিক আছে? না, 10 11 17 19 আসবে না?
Yes,
জি স্যার।
19. So my total is 19 and my mean will be
3.8.
3.8, yes, sir.
তো স্যার আপনি যদি একটু চিন্তা করে দেখেন, আমি কিন্তু b0 ধরে রাখছি আপাতত, ঠিক আছে স্যার, মানে
Yes.
just for the sake of convenience. And আমরা when we do partial derivatives, that is our assumption, right? Assume one variable is fixed and just vary one. ওইভাবে তো আমরা partial derivative বার করি না
ইয়েস
স্যার?
স্যার। ইয়েস।
Okay, so this is not an entirely bad assumption. I understand there's some, I am bridging over many things here, but for the sake of the discussion, let's just say that I have 2, I have 1, and I have 3. আমি ক্যালকুলেট করছি, এখানে আমার এরর ভ্যালু হলো 1.2, এখানে আমার এরর ভ্যালু হলো 3 এর জন্য কত আসছিল? 2.2, আর 1 এর জন্য আসছে 3.8। আমি যদি এই তিনটা পয়েন্টে এখন একটা গ্রাফ আঁকতে চাই অফ মিন অ্যাবসলিউট এরর, আমি তো একটা মিন অ্যাবসলিউট এররের গ্রাফ আঁকতেছি, তাই না স্যার?
Yes, sir.
Yes,
And our
sir.
function that the mean absolute error. So does it not make sense that my graph is going to look something like this?
Yes, sir.
এতটুকুতে কোনো সমস্যা?
No,
No,
sir.
Okay, so that's why I said that the minimum value is probably not at exactly 2, but it is close by. Make sense?
yes, sir.
Yes.
So এখন যদি আমরা একটু আমাদের গ্রাফটার কথা চিন্তা করি, তো গ্রাফটা ধরেন এরকম কিছু হবে। হবে না?
Yes, sir.
Yes, sir.
I mean, really, the slope probably should be the same on both sides, but you know what we're doing. So my mean absolute error, when I'm plotting it against the parameter A, looks something like this. We're happy so far?
Yes, sir.
And if I plot it against the parameter B, it would also have a similar presentation. Maybe point টা হয়তো shift হবে, ওটা হয়তো 0 কাছাকাছি হবে minimum point টা, কিন্তু এরকম কিছু একটা হবে স্যার।
জি স্যার।
Okay.
Yes, sir.
Really, if you look at it from a 3D perspective, if I was looking at from a 3D perspective, if this was A and this was B, then what I'm really doing is I'm plotting a cone. I'm plotting a cone with the sharp points. I'm mean absolute error using 2 parameters would give me at B equals to 0 and at A equals to 2, B equals to 0 and A equals to 2 would roughly be, not A equals to exactly 2, but around 2 would roughly be the minimum point of my 3-dimensional cone. Did that make
Yes.
sense? Okay. I'm obviously looking downwards on the cone, right? So I'm looking downwards from top. But that is where I should have approximately my minimum value.
Yes, sir.
Yes, sir.
Okay. So the point is actually now quite simple, right? If I start off at a random place in this cone, if I start off with a random place in this cone, in fact, let's forget about the cone for now, and let's just come back to this graph. If I'm initializing A and B randomly, then that means that at least for this particular, only just for A, I would be initializing it at some random point A along this line here. আমি A এর একটা ভ্যালু এই লাইনেই তো randomly initialize করব, এর বাইরে তো আর কোথাও থেকে initialize করতে পারবো না।
Yes, sir.
So for a random value here, so let's say I have randomly initialized A to be here, আমার প্রথম initialization. So that would correspond to a loss value somewhere here.
Yes, sir.
Okay. So now tell me, if I am at this point, আমার A ভ্যালুটা কি বাড়ানো দরকার না কমানো দরকার?
Sir, closer to 0, sir. তাহলে আমাদের বেটার এররটা কমবে অনেক।
আমাদের আমরা যদি এর ভ্যালু, আমাদের এর ভ্যালু এখানে লেটস সে approximately -1, আমার যদি এই পয়েন্টে, so I want to get to this point, yes?
Yes, sir.
So that's my target point. I know this now because I'm dealing with a very simple function. আসলে যখন আমরা একটু কমপ্লিকেটেড ফাংশনে যাব আপনারা হয়তো এটা ভিজুয়ালাইজ করতে পারবেন না, but you know the math stands. If I am here at this point and then I want to move to my optimal point here, move closer to my optimal point, do I need to increase the value of A or do I need to decrease the value of A?
We need to increase
Increase the value of A.
I need to increase the value of A. If I chose a random point here, then would I need to increase the value of A or decrease the value of A?
Decrease the value.
Decrease.
Then I would now need to decrease. Okay. Now, hypothetically only, if for some other reason my graph looked like this, okay, then then for this value of a here, which would be এখানে, for this loss function, আমার কি এই a ভ্যালুর জন্য ভ্যালু কমানো দরকার না বাড়ানো দরকার এখান থেকে এখানে আসার জন্য?
কমানো দরকার স্যার।
কমানো দরকার। Okay, so I guess what I'm trying to communicate is whether you increase or decrease the value of a parameter is dependent on the plane of the loss function. Make sense?
Yes, sir.
এতে তো কোনো সমস্যা? And I'm speaking about plane because, you know, in general, we're not going to deal with just one dimensional. We're going to deal with a multi-dimensional, multiple parameter, multi-dimensional cone or high dimensional loss function. So really what we'd like to do is we'd like to make sure that a valueটার কোনো magical property নাই. It's only because on the loss plot এটা এই জায়গায় আছে এবং এটা এই জায়গায় যাওয়ার জন্য ওকে কোন দিকে ট্রাভেল করতে হবে নাম্বার লাইনে, in this case it has to go to the decreasing side. But for this loss function, the one that we're really after, it now needs to go to the increasing side.
যদি বড় ডেটা সেট হয় কখনো কনফিউজিং হওয়ার মানে লাইক মিনিমাম পয়েন্টটা দুইটা অথবা তিনটা হতে পারে কিনা, লাইক কার্ভটা সাইন কার্ভ মতো এরকম সম্ভাবনা থাকে কিনা?
Look at the form of the function and why don't you tell me? No.
এটার ক্ষেত্রে তো পসিবল না স্যার। না, আমি বললাম যে বিগ অনেক বড় বেশি ডেটা থাকলে ওখানে যদি নন লিনিয়ার ফরম্যাটে ক্যারেক্টারিস্টিক্স থাকে।
So definitely sir, মানে absolutely the plane of the loss function when we come to do neural networks is not necessarily convex. You're right. অসম্ভব। ওকে,
তখন তো স্যার আমাদের কোন দিকে মুভ করব কনফিউজ থাকবো স্যার, কোনটাকে নিব আমরা?
So there is so one of the things that we have to understand is two things. One is we're actually not interested in the optimal point. মানে আপনারা চিন্তা করেন, আপনারা তো কম্পিউটার সায়েন্স পড়তেছেন, তাই না? এখন আপনাকে এসে কেউ একজন বললো যে আমাকে এই একটা ফাংশন লিখে দাও, আর আপনি একটা ফাংশন এটা এস্টিমেট করে দিবেন। Really, your job is to give a function that works, that is good enough for the purpose. You don't actually care whether it's the optimal function or not. Do you really care whether it's an optimal function or not? আপনারা কেউ মানে আপনাকে আমি বললাম যে আমাকে একটা মেশিন লার্নিং মডেল দেন যেটা আমাকে কালকের স্টকের দাম বলে দেয়। আমাকে যদি স্টকের দামগুলি এমনভাবে বলে দেয় যাতে করে আমি শেয়ার মার্কেটে টাকা বানাইতে পারি, তাহলে আপনি কি অপটিমাল ফাংশন পাইছেন কি পান নাই তাতে আমার কিছু আসে যায়?
অপটিমাল স্যার এমনি একটা মডেল বানানো তো স্যার 90 থেকে 95% অ্যাকুরেসি ম্যাক্সিমামই পায়, লাস্ট 5% নিয়ে তো স্যার রিসার্চ এত দিতে পারে স্যার।
But even if you have a model which is 100% accurate, it does not necessarily mean that you've reached the optimal point with respect to the training data. It just means that it's 100% accurate. Did that make sense?
No sir, training data যদি 100% accurate হয় তাহলে আমার টেস্ট ডেটা তো অনেক বেশি লস হবে, অনেক বেশি মানে
No, but what I'm saying is even if you find a function that achieves 100% accuracy on testing data as well, forget about training data, testing data achieve করছে, that still does not mean that you've reached the optimal parameterization of the function.
No
All
sir,
it means is you've achieved the parameterization that works well. Did that make sense?
Yes sir.
মানে আমি কি এটা বুঝাইতে পারছি স্যার?
জি স্যার।
মানে আপনারা কিন্তু আলটিমেটলি আমরা মেশিন লার্নিং প্র্যাকটিশনার্স হিসেবে we really don't care whether we get the optimal point or not. What we really care is whether it's good enough.
Yes sir.
Okay, মানে so, and particularly with the case of neural networks, the loss plane is definitely very, very, very bad, and it's worsened because of the fact that we don't calculate loss over all the training data. We calculate it over batches. That means আমরা আসলে যে লসগুলি ক্যালকুলেট করতেছি মানে proper loss is not may not even be representative of the true loss function. অনেক ঝামেলা আছে। Point though, and this is where we say that it works, and because it works, that is why you guys are studying it. Make sense? Okay.
Yes, sir.
You can show, for example, there is a proof that stochastic gradient descent, not mini batch gradient, stochastic gradient descent it is bound to converge to the optimal point, but it may take a very, very, very long time. So the algorithm will always converge to the optimal point, stochastic gradient descent, irrespective of whether the loss plane is optimal or not. Sorry, is convex or not. But it may just take a very, very, very long time. Point is, most of the time we don't care. What we care about is the fact that then the optimality is not an issue. Okay.
Sir,
Yes.
one question, sorry.
Yes.
Stochastic gradient descent will always give us the minimum regardless of if the cost function is convex or not?
Yes, that's because the way that stochastic gradient descent works is by its nature, because of its randomness. Even if you're stuck in a non-optimal saddle point, because of its randomness, you're eventually going to get kicked out of it.
Oh, I see.
Did that make sense?
Yes. Thank
Okay. So, and if you keep on calculating your losses per cycle, you can keep track of where it was that you hit the optimal point. Make sense?
Yes.
Yeah. So stochastic gradient descent is guaranteed to converge, provided you have a lot of time. Okay.
Yes.
Okay. So, আচ্ছা, so এতটুকুতে তো কোনো সমস্যা নেই। Hopefully, মানে এই গ্রাফে আচ্ছা।
No, sir.
So the observation that we're going to do is this, right? The observation we're going to do is this: that if dl by dA is positive, that means that the point I have selected is at a place in my loss graph where I am in an increasing state. Did that make sense?
Yes, sir.
And if my dl by dA is negative, then I am at a place in my loss graph where my loss is decreasing.
Decreasing state.
ঠিক আছে?
Yes, sir.
Which now means, it's quite simply, that if my derivative is negative, I really want to add some value to my parameter so that it moves closer to 0. So my derivative moves closer to this point. Sorry. So if my derivative is negative, I want to increase my parameter value so that I have a chance of my derivative eventually coming to this point, where in this case the derivative is undefined. Okay. But here I want to decrease the value. Is there no problem?
No, sir.
So while the exact value of the loss may not give me an indication of what to do, but the derivative of the loss with respect to the parameter can tell me what to do with the parameter. Make sense?
Yes.
এতটুকুতে কোনো সমস্যা?
No, sir.
All right. So this is what we're going to do. We're gonna quickly write out an algorithm that helps us do this. Initialize theta randomly while not the end of the world. And it's next class where we're going to change this for us. Okay. While not the end of the world, calculate L using ঠিক আছে? লস ক্যালকুলেট করতে পারবো?
Yes, sir.
Calculate dl by dA and dl by dB. এই দুটো ক্যালকুলেট করতে পারবো? Yes, no?
Yes, sir.
Yes, sir.
That is
Okay.
differential.
A is equals to A minus sine B equals to B minus sine where sine, so sine of x is equals to minus 1 if x is less than 0 or 1 if x is greater than 0. You'll see that I have conveniently, let's just make it. While x equals to 0, and for our sake, let or x is undefined. Okay. So, does this make sense?
Yes.
So what we're simply doing is we're saying initialize theta randomly, calculate L from f hat of f hat parameters by the current theta, calculate the derivatives of the loss with respect to the variables, which we can do, মানে এটা তো করা সম্ভব। আপনি যদি এই ফাংশনটা দেখেন, আমরা কি সবসময় dl by dA এবং dl by dB ক্যালকুলেট করতে পারবো না?
হ্যাঁ স্যার, পার্সিয়াল ডেরিভেটিভ করবেন স্যার।
পারবো তো, কারণ আমরা তো a এর ভ্যালু জানি, b এর ভ্যালুও জানি। কাজে মানে আমরা we just use calculus of multiple variables, right? Partial derivatives, you guys have learned this, right? So given that we know this, we can do it. করার পরে all we're going to do is we're going to update the parameters by saying if a এর ডেরিভেটিভটা যদি নেগেটিভ হয়, নেগেটিভ হলে -1 হবে, -1 কে আমি মাইনাস করলে +1 হবে, তার মানে আমি a কে 1 করে বাড়াচ্ছি। আর যদি a এর ডেরিভেটিভটা পজিটিভ হয়, তাহলে পজিটিভ হলে সাইন পজিটিভ হবে, তাহলে আমি a কে 1 করে কমাবো। আমি এখানে 1 করে বাড়াচ্ছি বা 1 করে কমাচ্ছি। সো ডেরিভেটিভ পজিটিভ হলে 1 করে কমাবো, ডেরিভেটিভ নেগেটিভ হলে 1 করে বাড়াবো। মেক সেন্স?
ইয়েস স্যার।
ওকে, আর বি এর ক্ষেত্রেও ঠিক এক্স্যাক্টলি তাই, because there should be no difference in what we're going to do. Okay, and if we hit a point where x is 0, well, in this case, if we hit a point where either the derivative is 0 or the derivative is undefined, then we don't change it, because for our function that we've chosen, this is fine. তার মানে ওই সময় এসে আমি b কে আর চেঞ্জ করব না। Make sense?
Yes, sir.
Yes, sir.
Okay. Now we're gonna finish the class here today. If there is any issues with what we've covered so far, any whatsoever, please make sure, like this is for each and every single one of you, because in the class I only hear 3 or 4 people speaking, right? And if there are any issues with any of this, please bring it up at the beginning of the next class, because if this might be very easy for a lot of you, maybe, or it may be just completely not something that you are getting right now. I don't know. But if you've got a problem with any of this, I would much rather that we spend time and get this clarified now, because when we come to do back propagation, I'm just going to assume that a concept clear. Okay, and we still haven't come to gradient descent. Well, we've come to a Pocha part of gradient descent. We will finish gradient descent next class, and then I would like to talk about what is it that we can replace this by. Okay. Okay. আজকে আসলে project related কথা বলার হয় নাই. You guys have a look. What I'm going to try and do is I'm going to try to post a list of projects and potential mentors for the project over the weekend. After it, we can hopefully have a discussion next class.
Okay, sir.
Thank you, sir.
Let me take your attendance. Giant Nathini. Attendance near me. Okay. So, Sheikh Asif Murshid.
Present, sir.
Thank you, sir. Farah Bushra.
Present, sir.
Thank you. Khandukar Mihrab Rahman.
Present, sir.
Thank you. Iftikhar Ahmed Udoy.
Present, sir.
Thank you. Amrijit Bishash.
Present, sir.
Thank you. Muhammad Abdullah Al Mamun.
Present, sir.
Thank you. Muhsin Kamal Chaudhary.
Yes, sir.
Thank you. Sanaullah.
Present, sir.
Thank you. Al Mamun.
Yes, sir.
Thank you. Sahil Ajmaish.
Present, sir.
Thank you, sir. Jahidul Islam.
Present, sir.
Thank you. Muhammad Usama bin Hussein.
Present, sir.
Thank you. Firdaus Ziaul Islam.
Present, sir.
Thank you. Muhammad Rakib.
Present, sir.
Thank you. Hasibul Hassan.
Present, sir.
Thank you. Rubaid Kubir Tanmoy.
Present, sir.
Thank you. Eric Upol Bishash.
Present, sir.
Thank you. Jannat Ara Firdausi Raya.
Present, sir.
Thank you. Anand Ghosh.
Present, sir.
Thank you. Muhammad Mushfiqur Rahman.
Present, sir.
Thank you. Muhammad Shahjalal Mondol Niloy.
Present, sir.
Thank you. Sadia Afrin Tamanna.
Yes, sir.
Thank you. Muhammad Mushfiq Uddin.
Present, sir.
Thank you. Tamalika Bukshi.
Yes, sir.
Thank you. Sadia Alom Tumpa.
Present, sir.
Thank you. Muhammad Mehdi Hassan.
Yes, sir.
Thank you. Muhammad Rifat Ansari.
Present, sir.
Thank you. Ifran Rahman Nijum.
Present, sir.
Thank you. Rokia Siddiqa.
Present, sir.
Thank you. Salman Mim Sahib.
Present, sir.
Thank you. Ausaf Mahmoud Lisan.
Present, sir.
Thank you. Muhammad Tasneemul Hassan.
Present, sir.
Thank you. Nahid Hussein Jibon.
Yes, sir.
Thank you. Udayan Shaha Upol. 9. Muhammad Ishtiaq Hussein Junaid.
Present, sir.
Thank you. Munjur Hassan.
Present, sir.
Thank you. Mushtaq Ahmed.
Present, sir.
Thank you. Muhtasin Mashrur Adit.
Present, sir.
Thank you. Muhammad Abu Ammar.
Present, sir.
থ্যাংক ইউ স্যার। আবু আম্মার সাহেব বোধহয় আমাকে একটা ইমেল পাঠাইছেন স্যার।
জি স্যার।
আচ্ছা, আমি স্যার এখনো পড়ি নাই। এটা কি জাস্ট গ্রুপের ইনফরমেশন?
জি স্যার, কি স্যার গ্রুপের ক্ষেত্রে স্যার, কি স্যার 5 জন।
5 জন? আল্লাহ, 5 জন স্যার। I better have the most amazing project ever to come out of the world ever. কি বলছেন স্যার? I can see the Nobel Prize in my grasp due to Mr. Abu Ammar and his group. ঠিক আছে স্যার?
জি স্যার।
জি স্যার, ঠিক আছে। 3 to 7 পাস করছেন স্যার?
জি স্যার।
আলহামদুলিল্লাহ, ঠিক আছে।
আলহামদুলিল্লাহ।
Okay, assalamu alaikum everyone, bye bye.
Sir.
Oh, হ্যাঁ, go ahead.
Salam, sir.
স্যার, আসসালামু আলাইকুম।
ওয়ালাইকুম আসসালাম। ম্যাডাম, কেউ কি কিছু বলতে চাইছিলেন?
Yes, sir. Sir, can I speak to you for a few minutes?
Yeah, absolutely. You want to speak now or do you want to wait for others to go?
Sir, I'd rather wait for others to go.
Okay, that's fine. So, Manusjan, যাওয়ার পরে we'll talk.
Yes, sir.
Sir, same.
Let me stop the recording first.